Me and maybe you, depending on where you're at, I like identifying things that are like terms. You can do that any way you want. You could mark that with 2 lines, 1 line, and then circles maybe. You know, just to make sure that I don't make any mistakes, I usually write an extra line of shuffling so that I don't forget to maybe bring a negative that's attached to a term, right? So I always rewrite the line with all the shuffle happened. Okay, so you get 3x squared minus 7x squared. That takes care of the 2 single lines, and then I'm going to have minus 3x plus 8x. That takes care of the 2 double lines, and then the 2 circles, plus 5 minus 9. Now you can just do the math because you've grouped everything together. You can combine the x squareds together. You can combine the x's together. You can combine the numbers together, the constants. Okay, so 3 minus 7 with an x squared on it is what that is. That's negative 4x squared. Negative 3 plus 8 is going to be plus 5x. 5 minus 9 is going to be minus 4. Okay? That's important because if I give you a question that's all shuffled like this, or we're combining 2 trinomials, and I ask you to solve the question like I did maybe in the review yesterday, one of those questions, where you're setting the quadratic equal to the line, you have to be able to collect like terms and factor. And if you mess that up, either you're definitely gonna get the wrong answer if you can't combine the like terms. But even if you did combine the terms correctly, but you forgot a sign or something, that quadratic's not gonna be factorable likely. And now you're gonna be sitting there staring at something, wasting time that's not factorable, just because you've made a sign error, combining terms together. So take that extra step, make sure you're bringing the whole term, right? So for instance, this term there, that negative 3x is negative 3x. Wherever I put that negative 3x, that negative has to go with it. That's important, okay? Okay, you can't mess that up because you're gonna stare at something that's not factorable as a result. You're gonna waste time and get stressed out over something that shouldn't happen, okay?
Is that factorable?
Can you find 2 numbers that multiply to 16 and add to 5?
No.
No, I don't think so. If you really wanted to talk about whether or not that had solutions at all, we could talk about the discriminant, which is not the point of what we're doing here. Well, the quadratic formula is a part of it is the discriminant. You don't want to do the quadratic equation if it doesn't have solutions. Is that fair?
Yeah.
You're wasting time again. So the discriminant's nice because it'll tell you whether there's solutions and how many of them there are, if it's 1 or 2. But if it's 0, don't use the quadratic equation. It's not going to give you anything. It's a waste of time. Okay? What about this one? This is here for a reason. It's minus this whole piece. You need to distribute that negative in. Okay? Identify the stuff that are like terms. So it looks like x squared y, negative 5x squared y. That would be one like term. I'd have 2xy, that'll have 2 lines under it, with negative 7xy, and then a 3x, the negative 3x, you could circle the 2x terms. I'm going to regroup them. X squared y minus 5x squared y plus 2xy minus 7xy minus 3x minus 4x. Okay, good check for you. Just like if you're doing these questions or working through problems and you end up in a situation like this, I know that there are 6 terms in the initial line. Make sure that you got 6 terms here so that you don't miss any, right? Because, again, you miss one, you're in trouble. Those are silly. Those are little silly errors that you don't want to have happen, okay? Okay, so now we can do the subtraction of stuff. So x squared x squared y minus 5x squared y. That's just 1 minus 5 with an x squared y on it. That sounds like negative 4x squared y. 2xy minus 7xy. So that's just 2 minus 7 with an xy on it. Negative 5xy. And negative 3x minus 4x is going to be negative 7x. Okay? All right, let's go to the next. I think maybe this is where people are going to start to get a little bit awry. We do work like this in grade 9. It's called like your exponent laws or power laws, and then we assume you know them in grade 10, and then we revisit them in order to apply them in grade 11 in the exponentials unit. Okay, so this is a simplification of like your use of quotient law. Like these are all power laws, right? They're summarized there. So what it says is the most important part is that the bases match in order to apply this stuff. So the base being the x. Okay, so what you're seeing here is because the base matches between the two things that I'm multiplying, I can add the exponents. Okay, for something that the bases match and it's in quotient or division, I can subtract the exponents. It's your quotient law. And then this is just kind of some distribution. Okay, so you're just distributing distributive power, okay, or the distributive law. You're just distributing that a into the xy. Okay, so for here, you've got three things. You've got some work that you can do with numbers. You've got some x's and you've got some y's. All of which, oops, you have basically three different bases there. They're the three different colors. And that's where you can do the work. So you can reduce 12 over 18. What is 12 over 18 reduced? Okay, 2 over 3. And then I'm just going to apply my power law. So I get x squared minus 1, y 8 minus 3. And I can rewrite it. Oops. Okay, I'm using that quotient law in the middle. Bases match. X and y are the two bases. Because they're divided, I'm subtracting the exponents that I see there. That's your simplified expression. Are we okay? Now, I do this a lot with the grade 9s. Okay. If you need to do this, you can. If not, don't. It's totally up to you. I'm recognizing right now, I'm looking at the coefficients in this question. And I recognize that 5 and 15 are related. Are 4 and 32 related?
Yeah.
How? Okay, 4 goes into 32, right? Right? So I remember with multiplication, it doesn't matter what order I multiply things in. So I'm just gonna shuffle this around. You don't have, like, there's all sorts of ways to do this, but I'm gonna write 4x squared y 7. I'm gonna bring the whole denominator here over. Okay. And again, I'm just doing this. I don't know if I would do this on a regular basis now that I got the hang of it. I've been doing it a while. It's maybe the same for you by the time you get to grade 11, but just so everybody's on the same page and we see what's happening. What do you mean? That's what I'm saying. What did I say? That's what I mean. Once you get to grade 11, you might not need to do this anymore. That's what I'm saying. You're in grade 11. Once you're here, you might not need to do it anymore. Or maybe you need to. I don't care what you do. You know what I mean? Okay. Thanks for the contribution to the lesson, buddy. Okay. You can shuffle the denominators around. I did that because now I can see 4 goes into 32 easier than 4 didn't go into 5. And 15 divided by 5 is a number that I like. And then I can just use my power laws to reduce things. Okay, so I'm going to go 4 over 32. What's that? 4 over 32, not 32 over 4. Ricky? It's 1 over 8. So they're both divisible by 4, right? So you have 1 over 8. And now I can go x squared minus 1. Y 7 minus 5. And that's going to be multiplied against here. Maybe that's okay. 15 divided by 5 is 3. X 6 minus 4. Y 8 minus 6. Is everyone following what's happening there? We have to do with this. There's going to be more complicated questions in the exponential unit, but I think we need to be able to compare like degrees of polynomials from numerator to denominator and simplify when we get into the rational expressions. So I think this is important. And more important when we get into the exponentials, but I think it's important as a skill set that we need. Okay, so now I can write 1/8 x. I might need a little more space, sorry. 1/8 x y squared. That has to be multiplied against 3x squared y squared. Let me get rid of that. Okay, now I'm using the first one. Bases match, I can add the exponents. So I'm going to get 3 times 1/8 is going to be 3 over 8. X cubed, I'm basically just counting exponents now, y4. That'll be a final answer. Okay, all I did there because I'm multiplying the two things together, the two terms. Actually, it'd be expressions.
You add the exponents?
You add the exponents. And 3 times 1 over 8 is 3/8. Okay? Wait. We'll just try to go through this as reasonably quickly as possible, so you have some time to work, okay? 3x times 2x, 3x times 4xy, 3x times negative 5x squared. 3 times 2, okay? If I look at the next one, you should have 4 multiplying, or 4 multiply, 4 factors that are multiplied, right? So we're going to get 8x squared minus 2x, okay, plus 20x minus 5. That's going to turn into 8x squared plus 18x minus 5. Everybody okay? Okay, a lot of this is grade 10 stuff, right? And if you can't do that, you need to get some help before it becomes a problem and a barrier to you doing the rest of the work. Okay? That's kind of always just the theme. Just don't procrastinate, don't kick the can down the road, get the help when you need it, or it's going to turn into a problem. All this stuff starts tying into one another, especially at this point in the game, once you reach grade 11. Now that I know that bothers you, I'm just going to keep saying it. Okay, this is the same thing. This is question D, because this is written 3x minus 4y. I'm just going to scoot through here, and if you need any help with this, individually, come talk to you, okay? You can expand that out, just like what we did in D, okay? F is a little bit more lengthy, okay? You can expand the 2 in from the beginning. That's going to be multiplied against 3x plus y minus x plus 4y times x plus 4y. Okay, and you can expand that stuff out. We can get, this could be a lengthy one. Save some space. 6x times 3x, 6x times y, negative 2y times 3x, and negative 2y times y. That's going to turn into 18x squared plus 6xy. A large part of this is like organization and keeping track of stuff. And if you're not organized and you're writing all over the place, good luck.
Minus 3xy, or 6xy.
No, it's positive there.
Where?
The y is positive on the second one.
Okay.
The next one, that one is going to be minus 3xy. Sorry. And then minus y squared. Okay, and then I'm going to minus, this is a little tricky, this question. Just go ahead. Bryce, you okay?
Negative 2y times 3x.
Oh, sorry. Dylan distracted me while we were talking about that.
Yeah, that's my
Sorry. I got the negative, but I wasn't paying attention to that extra factor 2 in there. So that's the negative 2y times 3x, right? So that'd be negative 6xy. And negative 2y too. Yeah, sorry, thank you. Okay, and then you just do the same thing here. Okay, you get minus x squared plus 4xy plus 4xy plus 16, sorry, y squared, sorry. Let me move it over. I told you it was going to be long. Okay, you can combine these two pair in the middle, these 0 pair out. So that's nice. 6xy minus 6xy is going to be 0. And then I'm just going to clean up the other one. So 18x squared, I missed the squared, nobody called, oh, no I didn't, it just moved. 18x squared minus 2y squared minus, okay, I got to distribute the minus sign in. That's kind of why I did this question. You got to distribute it to all 4 things, or 3 things anyway. Minus x squared, 4xy plus 4xy is 8xy, so minus an 8xy, and then minus 16y squared. Okay. 18x squared minus x squared would be 17x squared. There's no other xy's there, so we're going to have minus 8xy. And then we're going to have the negative 2y squared combined with the negative 16y squared to be negative 18y squared. Okay. I'm not sure if I need to do any more. Okay, if I do, I will.